Hello, in this video I'm going to explain how to find all the factors of a number, and I'll also explain prime numbers. Now in question 1 here, they want us to find all the factors of 46. All right, so all the factors of 46. So to review from the last video, a factor is a number that multiplies with another number to give you the product. For example, 2 times 3 is 6. 6 is the answer or the product. The 2 and the 3 are called factors because these are numbers that multiply with each other to give you something else. So what we have to do for this problem here is find all the factors. Now notice the word all, very important, because later on you're going to be find prime factorization. Not in this video, but later on in this module. So notice the difference. Here, find all factors. So when they say all factors, they mean every possible one, okay? And later on in this video, we'll cover what prime numbers are. Right now, we're not touching that. So when you're finding all the factors, there's no easy way to do it, but there's a systematic way to do it. So the systematic way to do it is to create a list. Now, what you should definitely know coming in, which will help you in this video, is the concept of divisibility, the divisibility rules that I covered in a previous video. So if you have not watched that, you definitely should watch it before this one, because I'm going to use the divisibility rules to help me find all the factors of a number. All right, so here we go. So we got to ask ourselves, what times what is 46? And as I mentioned before, we're going to do this systematically. So we're going to start with the smallest number and the easiest possible factors. And that is 1 times 46 equals 46. Yeah, that's pretty straightforward. So we're looking for factors of 46. All right, now, can I say 2 times something is 46 based on the rules of divisibility? Is 46 divisible by 2? Yes, it is, since the 6, which is in the ones digit, is an even number. All right, so yeah, there is some number that when I multiply by 2 will give me exactly 46. Now I know that's 23. If you did not know that, you would use long division on the side and figure that out. Can I say 3 times something is equal to 46? Well, I'm going to use the rules of divisibility again. I could use long division and try to divide 3 into 46, but it takes too much work. I want the quicker way to do it, and that's where the divisibility rules come in. For the number 3, the rules say add the digits. 4 plus 6 is 10. And then you ask yourself, can 3 divide into 10 evenly with no remainder? The answer is no. So 3 does not divide into 46. Does 4 divide into 46? Well, let's see. You think of the multiplication tables, right? So 4 times what? 10 is 40. 4 times 11 is 44. 4 times 12 is 46. Nah. Nope. Does 5 divide into 46? No, because the ones digit does not end in 0 or 5. Does 6? Well, 6 times what? 6 times 8 is 48. Close, but no. Does 7? 7 times 7 is 49. No. Does 8? So here's what happens. I got to the 6, the 7, and now I'm at the 8. I'm back at 8, and I'm saying 8 times 6. I already did this earlier, right? Because I said 6 times 8. It's the same thing. So once you get to the point where you're basically switching numbers and now are just reversing these, you know you're done. So the answer to this question is 1, comma, 2, comma, 23, comma, 46. So you're going to list these in order with commas in between as they say so here. And if there were factors that appear twice, you would list it once. But nothing appeared twice here. So let's type that in there and see if that's what they're looking for. 1, comma, 2, comma, 23, comma, 46. All right, so that's how you find all the factors. Now we got a couple of these. It's going to be the same technique regardless. So here the number is 250. Nice big number. Same technique though. Same technique. Here we go. 1 times 250 is 250. Can I use 2? I certainly can, because this is an even number. 2 times 125 is 250. And when you have big numbers like these, you can sometimes think of it as money, $2.50, right? So half of $2.50 is $1.25. $2.25 gives you $2.50. So sometimes using money can help you think of big numbers like that. Or you can use the alternative and then use long division. See, if you use long division now, you're not wasting your time because you know for a fact 2 does divide into 250 evenly. So you will not be wasting your time. Can we say 3 times something equals 250? Well, let's use the divisibility rule. 2 plus 5 is 7. 7 plus 0 is still 7. 3 does not divide into 7. 3's out. Can we say 4 times something? Well, not really, because look, we took half of 250, which is 125. And if we try to take another half of 250, we can't, because this is an odd number. Because if we could, that means, yes, 4 would go into 250. Now, we don't cover divisibility rules for 4, so I'm not going to get into that. And if you're not sure, simply just use long division, right? 4 into 250 and figure it out. All right, can we say 5 divides into 250? This ends in 0, absolutely. Now, 5 times what is 250? Think money again. 5 times what type of coin, which we don't use that often, by the way, will give us $2.50. The 50-cent coin, you said. Correct. Or you could have used long division. 5 into 250 will give you 50. All right, so let's keep going. Can we say 6 goes into 250? Well, we don't cover the rule for 6. Let's try it. It's real quick. Quick and dirty division here, nothing fancy. 6 goes into 25 4 times. 6 does not go into 10. So nope, that's out. 6 is out. Does 7 go into 250? 7 goes into 25 3 times. 7 does not divide into 40. Nope. Does 8 go into 250? 8 goes into 25 3 times. Nope. Does 9 go into 250? 9 goes into 25 2 times. 2 times 9 is 18. 70. Nope. 9 is not divided into 70. Does 10 go into 250? Yes, it does, because 250 ends in 0. 10 times what type of coin will give us $2.50? And you said a quarter, and you are correct. Now, for a lot of these problems that involve finding all the factors, in Math 50 for certain, Math 25, I'm not 100% sure, but once you reach 8 factors, you're done. They purposely made it so you're not going to be sitting here forever trying to find every single factor. All right, so this one should be, we got 8 factors. We got 1, 2, 5, 10, 25, right? See what I'm doing? I'm going down the line, and then I'm swinging back up. These are the factors, 50, 125, and 250. All the factors of 250. All right. Find all the factors of 100. Okay, so while I'm erasing the board here, start thinking about it. Start thinking about it. Try to get ahead of me here. All right. All the factors of 100. Same technique, just different number. Here we go. 100. 1 times 100. Let's blast right through this, right? 2 times 50. 3 does not go into 100. 4 times 4 quarters will give us $1. 5 times 20 is 100. 6, no. 7, no. 8, no. 9, no. 10, yes. 10 times 10. You notice we have the same number on both sides, so we're about to swing to the other side now, so we can stop right here. So in this case, we have 10 factors. Okay, so yeah, in this course they go over the 8, but just so you know, there's not going to be, 20, 30, and you're not going to be sitting here forever. 8 or 10 or something like that. So you want to find all the factors. So use the system that I'm showing you here. Now it says to, actually, so there's 9 factors, right? Because we cannot repeat a factor. So we have 2 10s here, but they don't want us to repeat. Okay, so always look at this blue. This is extra information, extra instructions you should always read down here. This will give you more information on what to type in into the answer. Especially helpful in Math 50. Always look at the blue wording. So after 10, we got 20. Then we got 25, 50, and 100. All right. Looks like a little bit more difficult problem, right? 147, that doesn't look too familiar. Looks kind of an oddball there. I think we can do it though, between me and you. Here we go, 147. The easy one, 1 times 147. Good. Now, this number ends in 7, which makes an odd number. What that means is that we cannot, there's no even number that will divide into 147. 2 will not, 4 will not, 6 will not, 22 will not, 8 will not, We're going to skip the even numbers. So that helps a lot. So then we're going to jump to 3. And let's use the rules of divisibility. 1 plus 4 is 5. 5 plus 7 is 12. 3 does go into 12 evenly. So yeah, 3 times something is definitely 147. Now, 3 times what? I have no idea. So I'm going to use long division to find out. So now I'm using long division because I know I'm not wasting my time. I'm going to get an answer. 3 goes into 14, 4 times. 3 goes into 27, 9 times. Again, quick and dirty, nothing fancy. So 3 times 49 is 147. All right. We're going to go to the next odd number, 5. Well, this ends in 7. It does not end in 0 or 5, so 5 is out. Does 7 divide into that? Let's find out. 7 divides into 14 2 times. Bring down your 7. 7 divides in 7 1 time. Oh, look, exactly. 7 times 21 is 147. 7 times 21 is 147. Okay, we're going to skip 8, go to 9. We'll use the divisibility rules, and we said this is 12. 9 does not go into 12. We're going to skip 10. And you know what? Once you get above 10, typically you're not going to, they purposely made it so you're not going to keep going forever. So it's pretty much single digits or maybe 10, the number 10 as far as these. And of course the original number, right? Whatever that is, which is the easy one. 1 times that number, whatever it is. So I think we have everything we need here. Let's put that in there and see what happens. 1, 3, 7, 21, 49, 147. All right, so this looks pretty good, right? Pretty reasonable. All the factors of 49. One times 49. Odd number, we're going to skip all the even numbers, right? Since this is odd, evens will not go into it. Let's go to 3. 4 and 9 is 13. 3 does not go into 13. Let's go to the number 5. Nope, it does not end in 0 or 5. Let's go to the number 7. Yeah, I like 7 because 7 times 7 is 49. And look, we reached a point where the numbers are the same on both sides. So we know we're just simply going to flip around now. So we're basically done, right? Now, here, interestingly enough, it doesn't say anything about listing only single factors if you have 2 of the same kind. So I'm not sure what they want exactly, but let's type in what we have, and then we'll go from there. We have a duplicate there, and in the previous problems, they didn't want that. Here, they didn't say anything. So let's see what happens. 1, 7, 7, 49. So I'm assuming they don't want the duplicates. They just didn't mention it. Okay, all right. All right. All right, so now we're about to we're going to shift gears a little bit. We're going to talk about a concept called prime numbers. Prime numbers. Okay. All right. A prime number is some number that its factors are the number itself and 1. Now, that's just a bunch of words, right? You probably have no idea what I just said. So let's take the number 5. And let's find all of its factors. Well, 1 times 5 is 5, right? Anything else? No, that's it. By the definition that I just gave you, this 5 is a prime number, because a prime number has its factors where 1 is a factor and that number itself is a factor and nothing else. So prime numbers have a big relevance in mathematics and also in business, in cryptography and online security and a bunch of other applications. So get used to prime numbers. All right. Now, so that's called a prime number, right? Because the only numbers that multiply to get that number is 1 in itself. Let's look at another number. Let's look at 6. Let's list all the factors for 6. Well, we got 1 times 6, but then we also have 2 times 3. Because for 6, there are other factors besides 1 times that number itself, then it is not a prime number. This is called composite number. Composite number, okay? Because this can be broken down into more factors besides 1 times the number. All right, so this is called composite number. And that's what they mean down here. Prime. Determine whether the number 8 is prime. Is it a prime number? Is it a composite number? Or is it neither? Let's look at the number 1. Let's write all the factors for 1. Well, 1 times 1 is 1. Now, I should have also mentioned here for the prime number that a prime number is a number where its factors are 1 times the number itself, but the factors have to be different. And that's to account for this situation. See, 1 is not prime. It's not prime because the factors themselves are not different, So that's part of the definition. So the factors have to be different. 1 times that number, of course they're going to be different, but not in the case where the 1 is involved. So that's why we say 1 is neither prime nor composite. It's that special case. All right, so get to know these concepts. All right, so let's look at the problem here. And let's see if we can figure out, is 8 prime or composite? Well, let's write all the factors. Let's see if we can figure it out real quick. 1 times 8 is 8. 2 times 4 is 8. And that's it. What do you think? Prime, composite, or neither? Composite, you said. Correct, because we have more factors than 1 times that number, which is 8. All right? These extra factors down here make this number a composite. So 8 is a composite number. All right, so now we have the number 37. The number 37. Well, you know what? I mean, let's look at some prime numbers here. Let's look at some prime numbers. Now, there are infinite amount of prime numbers. Okay, they just keep going on and on and on forever. Notice some patterns here. 2, believe it or not, is a prime number. It's the only even prime number. Okay, because 2, right, here's why. 2 is a prime number because 2 times 1 is 2. We have 1 times that number, and these numbers are not the same. So yeah, by definition, 2 is a prime number. 2 is the only even prime number. All other prime numbers other than 2 are odd numbers. But not all numbers Not all odd numbers are prime. All right, so here's what I mean. How about 15? Let's break that down. 1 times 15, 3 times 5. See that? 15 is odd, but yet it is not prime because of these extra factors down here. That's why 15 is not on the list. My recommendation is to do this. Memorize the first row and pretty much most of the second row. I would write these down in your notebook somewhere and get to know them really well, especially the 50, below 50, let's say. It's going to make life a lot easier if you know these by heart. And some of these you can deduce. Let's take the number 29, for example. Pretend we didn't know if it was prime or not. Actually, let's take the number 37, which is the problem itself. Can we say, does something times something equal 37 and not including 1 times 37? Well, let's see. 6 times 6 is 36. 9 times 4 is 36. What is it? 2 times 19 is 38. 7 times 5 is 35. Nah, nope. See what I mean? You cannot come up with two numbers that when you multiply will give you 37 besides 1 and 37, which makes 37 a prime number. There it is. So let's pick it. Determine whether the number is prime. We know the number 2 is the only even. It's the only even prime number. So yes, it is a prime number. All right, so that's how you perform prime number determination and also to list all the factors of a number. If you like my content, click on the like button, post your comments, and subscribe to my channel. Thank you for watching.